Hey, now that's the parent function, uh, x to the power 2, f of x is x to the power 2. So I'm going to show you how we graph that on a step by step, and then you go for the vertex, the axis of symmetry, what happens if I multiply the function by 5, and blah, blah, blah. What we do is we pick x equals to 0, some values for x, we plug in the function. So when x is equals to 0, 0 to the square, 0 times 0 is 0. So the point will be 0, 0. If x is equals to 1, 1 to the power 2, 1 squared is 1 times 1, y also be 1. So the first point is 0, 0. If x is 1, the y is also 1. If x is negative 1, so negative 1 to the power 2 is negative 1 times negative 1, which is 1 positive. So when x is negative 1, the y is also 1. For negative 2, do the same process. Negative 2 to the power 2 will be positive. For every time we square a number, it's going to be always positive. So when x is negative 2, the y is 4. So I have a little announcement here, but let's go. This is how we graphed the parent function. Now, what happens if I multiply the parent function by 5? So what happens is I will call x equals 0 again. 0 to the power 2 is 0. 0 times 5, 0. That's going to be my first point. If I call x equals 1, 1 to the power 2, 1, 5 times 1. So let me just do this quick. 1 to the power 2 is 1. 5 times 1 will be 5. 1 goes to 5. If I call x negative 1 to the power 2 is 1. 5 times 1, it's 5. When x is negative 1, y is also, so that is the function. So in this case, let me explain to you now quick what is the vertex. In the lowest point, we get x and y coordinates. In this case, 0, 0. That's the vertex. If it's upside down, like downwards, the vertex is the highest point. So 0, 0. The axis of symmetry, x equals to, is equals the x vertex always. In our case, the domain, all real numbers for quadratic functions, always. All real numbers. The range, y. Range is y. We go here, we take the lowest point. The graph is above exactly x. So every single number equals 2 or greater than 0. That's my range. Is a stretch or shrink. Look what was the distance between the original graph, the parent function, this one, to the x-axis. Was this distance? When you multiply by that number, look the distance between x and the blue graph, the 5x squared, is now bigger. So is a stretch because the distance between x and the graph increased. So now we're ready to go to the next question. So now we have a multiplying by a fraction. When you multiply by a fraction, same process, call x equals 0. 1/5 x squared. 0 to the power 2, 0 times 1/5 is 0. That's 0, 0. For this case, I'm going to call x equals to 5 because x 5 to the power 2, that will be 25. So that will be 1/5 times 25. What is 25? 25 times 1 divided by 5, which is also 5. And then when I plug in x equals to 5, I got y equals to 5. So 5 goes to 5. Let me put another column. So 5 goes to 5. So this way, if I plug in -5, I also get 25. That will be the same. So if I plug in -5, I also get 5. So this is my graph. Okay, so let me erase this right here. Okay, what is the vertex? Again, the vertex is the lowest point, x and y. The axis of symmetry is always the x vertex. The domain, all real numbers for quadratic function. Range, in this case again, everybody is 0 and above in the graph. In this case, we have a shrink. So look at the original graph. The distance between the parent function and x-axis was bigger than the distance from the yellow function, the new one. So the graph shrinks towards x. And what happens in this last case? Let me see if I have a last case. So when we have a negative number, we do the same process. The factor is multiplying by 3. Do not use the sign. The sign just indicates factor is 3, not -3. The negative sign just indicates a reflection. That means the graph will be downwards. So if we plug in 0, we get 0 squared is 0 times -3 is 0. If we plug in x equals to 1, so 1 is squared times -3, this is 1 times -3 will be -3. So that will be the first. If we put -1 squared, we also get 1. We'll get -3 again. So that will be -1 and -3. The graph goes this way. A quick thing. Every time the graph goes, we go left all the way down and then up. So here, all the time x increases because it goes to the right side increasing. And here y goes down. Y is going down, decreasing. It will happen here again, x increasing, y decreasing. Until here. Then here x still increases, but now y increases as well. So if the graph is upside down, it doesn't matter for, let's say, x also increases in this case. Here, y goes up, increases, until here. From here, x still is going to the right, x increases, and y goes down, y now decreases. Thank you for watching this lesson. Try to do some work, and then if you like the video, please like it and share that. Thank you.